there, I thought that I would do a really quick overview here of NOS uncoupling and the Fenton reaction. So first here, we're just looking at the general overview of a pyramid, which kind of gives the hierarchy of where to start when it comes to these chronic health situations. So generally when we look at a lot of chronic health situations, we come back to MTHFR, methylation. We hear a lot about MTHFR and folate, vitamin B12. That's not where we want to start. We got to start looking upstream and start asking questions. Why is there a problem? So generally speaking, we're going to look down here at some of these things, and I'm going to be talking about the NOS uncoupling and peroxynitrite primarily in this video. So here's an overview here of the methylation cycle and the pathways involved in methylation, or some things that are really tightly connected to that. So we have our urea cycle, we have number 1, and we have on the far left, next to that number 2 here is our neurotransmitter, the biopterin cycle. Number 3 here is the folate cycle. Number 4, the methionine cycle. Number 5 down over here on the left here is our transsulfuration or detox cycle. So here's another one that I really like that gets into a little bit more detail on that. And over here we have on the far left is the folate. In the middle here is the methionine, and down the bottom is the transsulfuration. They don't have the neurotransmitter. I'm going to get to that one next, but let's first look at this one, kind of a quick overview. So folate comes in here through our food through the folate receptor 1. Folic acid, that what we get fortified in most of our foods, goes through folate receptor 2, and then it actually slows down DHFR, but it has to get processed through that. So it kind of like slows down the very own process of what it needs to get metabolized. So we have unmetabolized folic acid in a lot of situations, especially if we have SNPs here in the DHFR. But that's kind of another topic for right now. So this comes down to MTHFR. So this is what we hear a lot about lately is MTHFR, and that's where this is at down here. Well, that makes the methylfolate, and it combines over here the MTR with methylcobalamin or method B12. It's got to have zinc as a cofactor. So those things are going to cycle around and make methionine, and then that folate's going to come back around and keep cycling here. So inside here, though, we have the B12. There's a little mini cycle here of that B12 getting to that methylated cobalamin here, so it can go up to methionine. After methionine, we need magnesium and ATP to make SAMe. SAMe goes off into like over 200 processes, with a lot of them dealing with our things like with our gallbladder with PMT. I think most of, like 70% of it goes to there. Well, that PMT is tied with the choline in our gallbladder function and fats and those kinds of things. So that's where 70% of it goes. We have the other of it goes to several other hundred processes, but our neurotransmitters is one of those main things that needs SAMe as a cofactor. The transsulfuration pathway needs SAMe. So then it comes around here to homocysteine is the next big thing that we hear a lot about. The homocysteine that keeps cycling around, or it can get eliminated out of the body down through the transsulfuration, the detox pathway. Also, homocysteine can come up here and recycle here through BHMT. So even if there's problems in MTR, MTRR, or MTHFR, we can still recycle the homocysteine here through BHMT. We need choline and zinc for that. And so that's another kind of secondary route that the body can take for that. So that's that cycle. Then we come down here to where the glutathione is. Oops. There we go. Okay, so we come down here to where the glutathione is. Well, there's a glutathione recycling also system. So this is why I'm not really a big fan right off the bat of giving glutathione, because if we can't recycle it, we can have problems and have some issues here. And so we can really then create some more feedback, negative feedback, those kinds of things. There's a lot of communication that goes on to kind of turn things up, slow things down, that sort of a thing. So what I like to do is I take the approach of let's support nutrition. Let's first make sure that our diet has these cofactors in it, because supplementing, we never can match the synergy that we're going to find in the food that our creator made. So zinc is a big one that we need. Magnesium, B6, selenium, having a really good copper balance, and iron, which leads to why we're talking about the Fenton reaction and the peroxynitrite and NOS uncoupling, because the iron and copper imbalances can really perpetuate that and make us more tendency to have that. And so why that's important then goes to our neurotransmitters. So here's the neurotransmitter pathway, and so this is why this is important here, is because this is where we're going to need that SAMe a lot and where the NOS uncoupling happens. So we have that cycle here that we saw in that first one here. This is the bioterin pathway. This is the urea cycle, and this is where that nitric oxide is. That BH2 is getting recycled around here for BH4. And so if this cycle here isn't happening, then the L-arginine is going to make a superoxide, or connect with superoxide. We're going to start having something called, here we go, peroxynitrite. So this is the way the cycle normally works. The BH2, BH4, this goes back and forth through the DHFR gene. It's going to couple here with arginine to go to citrulline and NADPH to NADP. And so this is how that cycle works. If that's not working, this is going to actually go make peroxynitrite, which then depletes the BH4, increases the BH2, and we have a really, really bad catch-22 scenario that gets perpetuated. This also depletes our melatonin. So that's why it gets, really wreaks a lot of havoc on our neurotransmitters. So we need the BH4 for the tyrosine, for tryptophan, for the arginine, so that goes down here. That tryptophan can go over here to that quinolinic acid, chironine pathway. The quinolinic acid is excitatory. We see a lot of that in autism and in some of the different neurotransmitter, the neuro diseases and situations. We got the dopamine. For our dopamine pathway to work well, we've got to have the SAMe, we've got to have enough BH4 and that iron balance for that to work. And so that's where that nitric oxide uncoupling gets to be very problematic. And so the more these get imbalanced, then it starts escalating. We start having other problems as well. So here's part of the issues that happen with the nitric oxide, with the we are making now that the O-No or peroxynitrate, we're going to start having lipid peroxidation, protein oxidation, protein nitration, inactivation of enzymes, and MMP activation. So the mitochondria is going to suffer from that. We're going to have apoptosis, DNA fragmentation, necrosis, and so all of those things then start escalating, and now it's going to influence the gene expression, because now we're having the building blocks that we're dealing with, the kind of like semi-damaged building blocks, and then it just kind of keeps going on and on and on. So here's a chart that I really like on the NOS uncoupling. So this kind of shows you the that BH4 there on the top, kind of left here, and the L-arginine are supposed to work together here with that NOS enzyme to recreate, to make makes nitric oxide. Nitric oxide is very, very beneficial, but there's also some nitric oxide that's not beneficial. So when we have the NOS uncoupling, what's going on is we have the peroxynitrite that's getting made here. And the peroxynitrite then leads down to lipid peroxidation, protein nitration, and we just start having that inflammation just keeps going on and on and on. And the L-arginine is something that can really fuel that system. That's why it's really important to look at, if we've got this uncoupling going on, that we're avoiding things like arginine, because while arginine normally is a wonderful thing to have, we need the L-arginine to help promote the BH4, this whole cycle, to help support the nitric oxide production. It also can be a bad thing if in the right conditions, in the right situations. So that's just something to be aware of. This superoxide here that comes over here to make the hydroxyl radicals is another very big problem that we can see quite often in these chronic health situations, where this superoxide gets made into the hydrogen peroxide through SOD, but then if we have a shortage of the catalase and it doesn't clear it on out to the water and oxygen, we can have a problem. So the other way to clear this is we need the glutathione on here with the catalase to make the water. So if we don't have enough glutathione, if we have that methylation cycle, things that we're not cycling down that glutathione, this here becomes a problem with that hydrogen peroxide here, and we can combine with iron to make the hydroxyl radical. So it just kind of gets these, webs here that go on happening. So whenever I see these issues of gallbladder issues, we've got to have nitric oxide. One of the things when you start seeing the sluggish gallbladder to start thinking is, what's going on with nitric oxide? Is there any other symptoms? Do we have any sort of labs that are pointing to some problems in the neurotransmitter pathways, in the transsulfuration pathways, in the methylation cycle, especially when I see a lot of neuro issues. I'm thinking there's an imbalance. BH4, since it's needed for those neurotransmitters, that NOS uncoupling is one of those upstream things of that. And so that's how it kind of all gets interconnected. So when we go and looking at that main pyramid, that's where we generally start, is with these things down here at the bottom, that NOS uncoupling, because we're going to have an imbalance of a lot of these other things if we don't have a healthy balance and a healthy cycle when it comes to that nitric oxide. The same thing like with the glutathione production. We need to make sure that we're having that balanced really well. And what happens when it comes to, we can, just replace some of these things, we can have a lot of negative feedback sometimes because there's just so many things that we've got to juggle. So I usually take the approach of, let's first support nutritionally, make sure we have a really good diet and lifestyle, do whatever we can that way to not be adding fuel to the fire, but then also to say, okay, what can we do to support generally nutritional wise those cofactors for those processes, because our body knows all of these what ifs going on. We can only guess the best that we can with the data that we have, with the symptoms of the labs and those kinds of things. But there's so much that I'm sure that we are missing, right? So I like to first, let's support with the cofactors. That way I'm not, accidentally giving something whenever really it was a negative feedback somewhere else and that kind of thing. It just makes it less for me to juggle when I'm just going to be giving the cofactors and taking things slower and letting the body take over. And really my goal is to support the body in restoring the health. And for me to say, okay, what is the battle it's dealing with? Where does it need me to support it? Where is it needing me to give it some extra building blocks? So that's pretty much a really, really quick overview of that NOS uncoupling and peroxynitrite and why it's so important and how it's connected to some of these other areas and how this whole these bottom three rows really are kind of the bottom, the whole foundation, because they are so tightly connected. But that's where we really need to start, especially whenever we have that MTHFR genes or really any of those genes. And what I have seen in the genetics testing that I have done is a lot of MTR, MTRR, SNPs other than MTHFR. I do see some SNPs in MTHFR, but it's not like, all of these people that I'm seeing are homozygous MTHFR. No, I see a lot of homozygous or a lot of heterozygous in every single one of the DHFR, MTHFD1, MTR, MTRR. There's one, the ACHC over there on that transsulfuration pathway that can be very, very problematic. Because we just don't know enough about that pathway to really say definitively, okay, this is kind of the direction things go or how things are positively, negatively affected. So that one's very, very, has a lot of surprises with it whenever we see SNPs in that particular pathway. So that's pretty much a general overview. If you've got any questions, you are certainly welcome to reach out to me. I always enjoy talking with others. And I hope that this gives you a really super quick, this is so very, 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 very fast, and there's so much more to it than this, but just to kind of let you, so you can kind of know, okay, a little bit general what's going on here when we talk about NOS uncoupling. I will talk to you later. Have a great day.